Right, in this video, I'm going to tell you how to set up a very basic grid. To do that, you would open Overture, you're going to get your series of menus, and you go with a new assisted project. Okay, new assisted project. And what this will allow you to do is create a uniform grid that you will collect data across. The reasons you would want to do this is it's the most, situations that you might want to do this. It's the most systematic way to collect data, and doing grids produces the best 3D visuals during post-processing. So if you have DX Vision software, you can create time slices in DX Vision software, and the best visuals will come if you produce data in a systematic grid. This is not always necessary, but it does drive standardization, and it's a systematic data collection across a given area. So here's how you do the very basic kind of version of this. When I pull mine up, it always gives me some sort of awkward distribution. But what you'll have here is grid, and then it'll give you step, and it'll give you length versus width. Okay, step, length versus width. So what do each of those mean? Well, length and width is basically the size of the entire grid. As you can see now, it says my width is 50, and it is 0 to 50. And then it says length is 500, and it goes on the bottom here, 0 all the way over to 500. We're going to adjust that. So rather than me kind of going down one by one, which is going to be a very long process, let's say I wanted to carry out a 10 meter by 10 meter grid to really cover an area that seems to be very congested. That's another reason that you would want to use a grid, is when you have very congested subsurfaces, grids will help you delineate those those features. And that's because a lot of times in two-dimensional view, you may see a lot of different hyperbola and you don't know what connects to what. But if you can look at it visually in 3D, top down, it can help you delineate what is what. So we'll go ahead and say, let's say 30 feet by 30 feet. Okay, so 30 feet by 30 feet. I'll go ahead and I'll bring up my keyboard. I will erase that and I'll put in 30. It's 30 feet. I'll go to my width. All right. I'll erase 30. X out. And now you can see here, if I zoom in, right? Zoom in, it's giving me my 30 feet by 30 feet. So in order to define how often I'm going to collect a swath, right, or a transect or a profile, that's where I go back to this T-step and L-step, okay? So for T-step, this is saying every 10 feet I'm going to collect a swath. Well, my entire grid is 30 feet by 30 feet. So if I do it every 10 feet, the resolution is going to be pretty poor, and it will not bring up a nice looking visualization in the DX Vision software. So what you really want to do is get much better resolution. So we can go down to, let's say, every foot, okay, we'll collect data, or every 2 feet we'll collect data. Okay, same thing with the length. Let's say every 2 feet we'll collect data. We'll go ahead and zoom on in. Move back over. And now you can see we have a grid with a 0, 0 point. It's 30 meters by 30 meters. And it's telling me every single 2 feet I'm going to collect another transect. When I go into data collection mode, it'll prompt me to show me which line I'm collecting next. And you'll collect in one direction over and over and over again. And then when you cut across the entire grid, you'll come back to 0 and you'll collect in a perpendicular direction. I recommend this for utility locating, or else you can alienate entire buried services, and that can be dangerous. And so if you want to collect perpendicular so you can identify everything, this is how you might do it. So flip scans, right? You can choose how you want to go about viewing it. I generally keep it as is. It'll tell you to go forward first and then come back and go perpendicular. That's basically how this works. That's the easy way to do a simple grid.